Imagine for a moment that the core intelligence of, well, pretty much every device you touch, your phone, your laptop, even the huge data centers driving AI, it all hinges on the expertise and maybe even the fate of just a handful of companies and nations. That's not some far-off future, that's right now. Today, we're doing a deep dive into this really dramatic shift in global semiconductor power. We're going to explore how Japan, which was completely dominant in the 80s, sort of faded, and how Taiwan emerged almost out of nowhere as this indispensable powerhouse.
Exactly. And for this deep dive, we'll be drawing on insights from a really thorough analysis called The Shift in Silicon Hegemony, looking at Japan's decline and Taiwan's foundry model rise. We've also got market share data, business model info. Our mission really is to unpack the why behind these massive shifts. And crucially, what it all means for the future of tech, especially, with AI taking off like it is.
Yeah, get ready for some aha moments here. This deep
Yeah.
dive is all about giving you that shortcut to understanding the really complex dynamics of what's arguably the world's most critical industry right now. So let's start back in the 80s. How did Japan become this undisputed king of semiconductors? They even had a name for it, right? Hinomaru Semiconductor. That sounds like serious national pride. It wasn't just luck, was it?
Oh, far from it. Japan's rise was meticulously planned. A key part was the VLSI project. Very large-scale integration kicked off way back in '74. This wasn't just throwing money around. It meant preferential loans, tax breaks, and crucially, shared R&D platforms. Think about it. Fierce rivals like Hitachi, Toshiba, NEC, all collaborating on basic research. It generated thousands of patents. It was a huge leap in manufacturing tech.
Wow, getting competitors to cooperate like that.
Exactly. And the results. By 1988, Japan had almost half the global market. By 1990, 6 of the top 10 semiconductor makers were Japanese. Incredible. They overtook the U.S. in exports in '86, and even in patents by '87. It was genuine dominance.
Okay, so the government strategy was key. But what about the companies themselves? How are they structured to make this happen?
That's the other crucial piece. The integrated device manufacturer, or IDM model. In the '80s, this was the way to do it. And IDM does everything: chip design, wafer fabrication, packaging, testing, sales, total vertical integration.
The whole 9 yards.
Right. And this fit perfectly with Japan's corporate structure. Many semiconductor divisions were part of these huge conglomerates, the Keiretsu. This gave them access to what you might call patient capital. They could make massive long-term R&D and factory investments without Wall Street breathing down their necks for quarterly profits, unlike many U.S. firms.
Yeah, so they could play the long game.
Precisely, and that model was perfect for the '80s market. Chips then were mainly for mainframes, telecom, high-end electronics. Quality and reliability were paramount. Made in Japan, quality became legendary, and the IDM model was built to deliver exactly that.
And this really comes into focus with DRAM, right? Dynamic Random Access Memory. Tell us about that story.
Oh, DRAM is the classic case study. Japanese firms like NEC, Toshiba, Fujitsu achieved, absolute dominance. They captured something like 70 to 80% of the global DRAM market. Their edge was just staggering: manufacturing efficiency, product quality, capacity, reliability, yield rates. They were unbeatable.
So unbeatable, it actually pushed others out.
Completely. It forced most American companies, even Intel, the pioneer, right out of the DRAM business. Only Micron and Texas Instruments really survived as major U.S. players. It totally reshaped the industry.
So just to recap Japan's golden age, you had national strategy driving R&D, Keiretsu providing patient capital, and the IDM model delivering unbeatable quality for the time. Sounds almost invincible.
It really did. But ironically, the very things that made it so strong, that vertical integration, that focus, also contained the seeds of its inflexibility, its later decline.
Right. Empires rise and fall. So even the seemingly invincible system started to crack. What happened? What were the pressures?
It was a combination of things, really. Huge pressure from the outside and internal issues bubbling up, too. First, the geopolitical vice tightened, mainly from the U.S. A big one was the Plaza Accord in 1985.
Ah, yes, the Plaza Accord, macroeconomics, right?
Exactly. Its main goal was to weaken the U.S. dollar, but for Japan. The yen nearly doubled in value against the dollar, incredibly fast, like 240 yen to 120. Suddenly, all Japanese exports, including semiconductors, became super expensive. And to fight off a potential recession from that,
Let me guess, they cut interest rates.
bingo. The Bank of Japan slashed rates, flooding the market with cheap money, which unfortunately inflated this massive stock and real estate bubble, the one that burst and led straight into Japan's lost decade.
Okay, so a macroeconomic earthquake first, then something more direct.
You got it. A year later, 1986, the U.S.-Japan Semiconductor Agreement. This was much more targeted, a surgical strike, you could say.
What?
The U.S. accused Japan of dumping selling chips below cost. The terms were harsh.
What do they demand?
Two key things. One, Japan had to guarantee foreign firms, mainly American, 20% of its domestic market share. Huge deal. Two, strict price monitoring to stop Japan selling below cost, not just in the U.S., but everywhere. That killed their low-profit, high-volume strategy, a core part of how they'd won the DRAM war.
Ouch. So their main competitive weapon was effectively disabled.
Pretty much. And the U.S. didn't stop there. While hitting Japanese DRAM with high tariffs, they gave South Korean companies like Samsung a much easier ride, very low tariffs. It looked a lot like a deliberate strategy to use Korea to box in Japan.
A really tough external environment then. But you said there were internal issues too. What went wrong inside Japan Inc.?
Yeah, absolutely. The external shocks were damaging, but Japan's own structural flaws and strategic mistakes were just as important. That IDM model, their greatest strength, it became a trap. The industry started shifting towards what we call a horizontal division of labor, meaning separating chip design done by fabless companies from the actual manufacturing done by specialized foundries. Japan's giant, rigid IDMs just couldn't adapt. They were built to do everything in-house. Splitting design from manufacturing, competing with nimble, specialized players, it didn't fit their structure.
So that battleship analogy from the source is apt, powerful, but hard to turn.
Exactly. The source nails it. IDM is the heavily armored battleship, powerful but slow. The fabless foundry model is like a flexible aircraft carrier group, specialized units, collaborating, adapting fast.
And they missed a market shift too.
Big time. The market shifted from mainframes and high-end gear to personal computers. PCs needed chips that were cheap and updated quickly. Good enough performance, price was king. Japanese firms are optimized for that high-end, over-engineered durability. They just couldn't pivot to the low-cost, high-volume PC market effectively.
And then the lost decade hit.
Right. The bubble bursts in the early 90s. Japan enters long-term stagnation. That meant drastic cuts to investment. Crucial R&D and capital spending for semiconductor divisions got slashed. They went from being stars to being seen as a ruse, a burden. Even attempts to consolidate, like creating Elpida memory from NEC and Hitachi's DRAM units, were ultimately too little, too late. It eventually went bankrupt.
So as Japan is dealing with all this perfect storm, something else is happening across the water in Taiwan. What was their secret sauce?
Yeah.
It wasn't just copying Japan, right?
Not at all. Taiwan's success was built on inventing and mastering a completely different model, the foundry model. This model totally separates the incredibly expensive part, building and running the factories, the fabs, from the chip design part.
Lowering the barrier to entry.
Massively. Before foundries, designing a chip meant you probably needed billions to build your own fab. The foundry model broke that. It enabled this explosion of fabless companies' firms that only designed chips. They could focus all their energy on innovation and then outsource the manufacturing to a professional, neutral foundry.
Like TSMC.
Exactly. TSMC is the prime example. This created a whole new ecosystem. And importantly, foundries like TSMC serve tons of different customers. Smartphones, PCs, servers, cars. That diversification protects them from downturns in any one market. Unlike IDMs often tied to one product line, foundries have more stable demand.
And TSMC. They seem like the absolute superstar here. How did they become so dominant, so crucial?
Well, TSMC, founded in 1987, was the world's first pure-play foundry. That's key. Its founder, Dr. Morris Chang, laid down a golden rule. TSMC will never design or sell its own branded chips. It will never compete with its customers.
Building trust.
Immense trust. Design companies could give TSMC their most valuable secrets, their IP, knowing TSMC wouldn't steal it or compete with them, and their rise has been phenomenal. By the 2020s, over 58% of the global foundry market. That's arguably a more strategically critical position than even Japan had in the 80s with DRAM. TSMC isn't just a factory, it's built this huge ecosystem around itself, providing advanced manufacturing processes, design tools, IP blocks. It's the platform the global fabless world runs on.
That's an amazing story of focus and strategy. What about the Taiwanese government? Were they playing the same protective role as Japan's government did for its champions?
No, a totally different approach. If Japan's government acted like a protector of its established giants, Taiwan's government was more like a shrewd venture capitalist. They focused on strategic leverage points, getting technology transfer, like from RCA back in the 70s, providing seed funding and R&D labs through institutions like ITRI, the Industrial Technology Research Institute, and then, crucially, spinning off companies like UMC and TSMC, bringing in private investment. They were a catalyst, a founding investor, but they didn't try to permanently shield these companies. They helped create an Asian Silicon Valley.
Okay, that makes sense for the foundry model's success. But, to really test the theory, we should look at where Taiwan didn't succeed, maybe. Did they only bet on foundries?
That's a really sharp question. And the answer is no, they didn't only bet on foundries. And the counterexample is really instructive. Taiwan's DRAM industry. While the foundry sector boomed, Taiwan also invested heavily trying to build a DRAM industry. But they really struggled against the established giants, especially Samsung.
What went wrong there?
Several things. They lacked their own core technology, relying heavily on licenses from others, which cost a lot and kept them behind the curve. They invested in fabs, yes, but not enough in the fundamental R&D needed to keep up. Plus, their business model was just too fragile for the brutal, cyclical DRAM market. Their market share actually collapsed from around 18% down to just 6% between 2006 and 2011, while Samsung soared. Even a government effort to consolidate the industry, the Taiwan Memory Company, failed. It really underscores the point. Taiwan's success wasn't some inherent national trait, it was the victory of the foundry business model. They chose the right strategy.
Okay, so the industry structure shifted. Now let's jump to the present day. With AI exploding, where's the action now, especially in memory?
Right, the memory market itself went through its own brutal consolidation after the Japan-US battles. You had the US pioneers in the 70s, Japan dominating the 80s, then Korea and the wider Asia-Pacific taking over from the mid-90s. Today, it's basically a DRAM triopoly. South Korea's Samsung and SK Hynix, plus America's Micron Technology. And Japan's last big player, Elpida, that Nechitachi merger, as we mentioned, went bankrupt in 2012. Micron bought its assets. That really marked the end of Japan's leadership in commodity memory chips.
Okay, end of an era there. But now AI is driving demand for something new, right? High bandwidth memory, HBM. What exactly is that, and why is it so vital for AI?
Yeah, HBM is a game changer, driven entirely by AI's insatiable need for data. Large language models like GPT-4 need way more data fed into the processors, the GPUs, than traditional DRAM can handle. It becomes a bottleneck. So HBM isn't just faster memory, it's a whole new architecture. Picture this. Instead of placing memory chips side by side, you stack them vertically, maybe 8 or 12 high.
Like a tiny skyscraper of chips.
Exactly. And you connect these layers with thousands of microscopic vertical wires called TSVs through Silicon VS. Think of them as tiny elevators for data. This 3D stack is then placed right next to the GPU on a special base layer called a silicon interposer. That whole package is called 2.5D advanced packaging.
Okay, complex stuff. What are the advantages?
3 big ones. First, massive bandwidth. We're talking over 1.2 terabytes per second for the latest HBM3E. Essential for feeding giant AI models. Second, lower power use because data travels shorter distances. Third, smaller physical footprint on the circuit board. Because of this, HBM is now standard for high-end AI chips from NVIDIA, AMD, and who makes HBM? Primarily that DRAM triopoly, SK Hynix, Samsung, and Micron.
Wow. That sounds incredibly difficult to make and put together. So what does this mean for the global supply chain? It can't be a simple picture anymore.
Not at all. It's definitely not a zero-sum game, no. The sheer complexity of HBM means no single country, no single company can do it all. Instead, we have this highly specialized, deeply interdependent global supply chain. Leadership isn't just about market share, it's about controlling critical technological bottlenecks.
So who controls what?
Okay, break it down. South Korea, specifically SK Hynix and Samsung, are the powerhouses manufacturing the actual HBM chip stacks. SK Hynix really pioneered it. Samsung's catching up fast. They dominate this part. But then you have Taiwan. Taiwan is the indispensable integrator. Those HBM stacks need to be connected to the logic chips, the GPUs, with incredible precision. That needs the most advanced packaging technology. And Taiwan, particularly TSMC with its CoWoS technology chip-on-wafer-on-substrate, has a new monopoly on packaging these high-end AI chips.
Yeah.
This CoWoS capacity is currently the biggest bottleneck in the whole AI hardware supply chain. Huge leverage for Taiwan. Other firms like UMC and ASE are involved too.
Okay, Korea makes the HBM. Taiwan puts it all together. Where does Japan fit in now?
Japan. They've staged a quiet comeback, but in a different role. They are the silent upstream hegemon. They dominate critical, high-tech, high-profit equipment and materials needed to make HBM possible. For example, the special machines needed for 3D stacking resin molding from TOA, wafer grinding and dicing from Disco, HBM testing gear from Advantest, largely Japanese. Mass production is impossible without them. And key materials, like the special adhesive film, non-conductive film, or NCF, needed to bond the chip layers. Japan's Resonac is the leading supplier.
So it's this intricate web.
Exactly. Deep interdependence. Korea needs Japan's gear and materials. The entire AI industry needs Taiwan's advanced packaging. Japan, leveraging decades of accumulated tech expertise, found this incredibly strategic, high-value niche.
What a journey. From Japan's 80s dominance through the IDM trap, Taiwan's foundry revolution, and now this complex HBM web. If you had to boil it down, what are the big takeaways from this whole shift?
It really is an epic story, isn't it? I think the core findings are: Japan's decline wasn't just one thing. It was that perfect storm, external shocks like the Plaza Accord and the Semiconductor Agreement hitting their finances and strategy, combined with internal rigidity. The IDM model just couldn't adapt. Taiwan's rise was fundamentally about a revolutionary business model, the foundry brilliantly executed by TSMC with its customer-first focus, and cleverly nurtured by a government acting like a VC. And remember, the DRAM failure, it proves Taiwan's success was about the model, not just the nation. The biggest shift. We moved from vertically integrated giants fighting zero-sum battles to a world of horizontal specialization, global interdependence, where cooperation and competition totally coexist.
Looking back at all this, what are the timeless lessons here? Things we can apply even today, maybe in other fast-changing fields like, AI development itself?
Oh, definitely. There are some profound strategic lessons. First, the paradox of success. What makes you win today can absolutely become your prison tomorrow. Japan's IDMs are a classic example. Organizational inertia is deadly. Second, ecosystem thinking beats product thinking. Taiwan didn't just win by making a product, they won by building a platform that empowered thousands of other innovators. Creating value networks is way more resilient than trying to own everything. And third, the role of government evolves. Japan's protectionism eventually stifled change. Taiwan's role as a targeted catalyst and early investor proved much more effective in fostering a dynamic industry.
Fascinating lesson. So looking ahead now, this fight for semiconductor leadership is obviously still raging. What should we be watching for?
Yeah, it's definitely not over. A few key trends stand out. First, supply chain restructuring. The U.S.-China tech conflict is forcing everyone to think about security and resilience. That could lead to more regionalized supply chains, especially for advanced chips like HBM, challenging the super-efficient global division of labor we have now. It adds cost and complexity. Second, the technology race is relentless. Moore's law is slowing, so the focus is shifting to new architectures, moving from FinFET transistors to gate-all-around, or GAA, using chiplets like Lego bricks, integrating different types of chips together. Mastering these next paradigms will define who leads tomorrow. And third, interestingly, Japan is dreaming of a comeback in leading-edge manufacturing. The U.S. is actually supporting this now, backing companies like Rapidus, which aims to make 2-nanometer chips using IBM tech. Japan seems to be trying to learn from its past, adopting a more open, collaborative approach this time.
It's just incredible how dynamic this all is. Almost like geological time sped up for an industry. It really drives home how interconnected everything is now. It's not about building walls around an empire anymore, is it? It's about being a critical node in a network that thrives on openness, but also fierce competition. Wow, what a deep dive that was. We really hope you found this journey through the silicon landscape as fascinating and eye-opening as we did. It certainly puts the brains inside all our modern tech into perspective.
Absolutely. Thanks so much for joining us for this look into one of the truly vital industries that's shaping everything about our future.
If you enjoy our channel, please subscribe, turn on the notification bell, and share it with others. Thank you, everyone.